Welcome back. Now I'll start from the problem number 9. This is chapter number 13. We will still continuing on the same kinematic problems, and these are depending three more problem I will show in displacement. Then I'll move on to velocity and speed. Okay. So in every segment, I'm trying to cover all the type of problem that could appear. Okay, so this is number 9. It says a farmer moves along the boundary of a square field of side 10 meter in 40 seconds. What will be the distance traveled in moving around the field and magnitude of displacement of the farmer. At the end of 2 minutes 20 seconds. Okay, so this is the question. A farmer moves along a boundary of a square field. Let me draw the square field first. This could be the representative of square field, and side is 10 meter. So as this is square field, you understand that every side is 10 meter. So all are 10 meter. But a square field, so what is moves along the boundary of the square field means is maybe started from, let's say, A, this is B, C, D. He moves along the square field means he is traveling all around the corner and coming back 10 meter in along of the side of 10 meter in 40 seconds. So that means he is covering the total square in 40 seconds. Okay. So what will be the distance traveled in moving around the field and magnitude of the displacement of the farmer? So you know the farmer is if it is starting point, let's say it is starting point. So from here he has started and moves around this field and coming back to this point again. So if it is coming back to the starting point, so displacement obviously it's 0. So for displacement after each 40 seconds, if it is taking time to cover this square field, is 0, and distance is equal to 4 into 10. So that is 40. So for each round, the distance when it is starting from A and coming back to A, the distance covering is 40, but the displacement is 0. So in 2 minutes 20 seconds means how many seconds? It is 140 seconds. So let me check. 140 seconds is how many times of 40, because if it is perfectly divisible, then there would not be any displacement at all. So it is how much it is coming? 4 2 7, so 3.5. Okay, so up to this 3 turns there will be no displacement, or only half turn. That means when it is 3 turn is done, then after half turn means from here to here. So that means at the last lap he has reached, this is the finish point. Okay, so the distance obviously will be multiplied with 3.5. The total distance will be 40 into 3.5. So that will be the total distance traversed. So that will be 4 into, and that is 40, 140 meter he has traveled as a distance. But the displacement for 3 turns it will be nullified because he is coming back to 0, that is starting point. But the last lap he has reached finally there. So the distance for the last lap or the ultimate lap is reaching at and ending at C. So this will be the displacement for him. So for 2 minutes and 20 seconds, ultimately he is reaching, which is distance as a diagonal apart from the starting point. So this is obviously we root 2 into the side 10. So so displacement for this time will be, displacement will be 10 root 2, and distance will be this one, 140 meter. Okay, understood? Okay, moving to the next problem. Problem number 10. It says an object is moving along a curved path. An object is moving along a curved path of radius. So although it is being said path and radius is given, that means the curved path is a circular path, that you have to understood. Curved path of radius, or it may not be a full circle, there may be a curved path which is of radius, but it is in a shape of a circle. If we complete that curve, it will form a circle. It reaches from A to B, from A to B as shown below. As shown below in figure, okay, in 10 seconds. Okay, find the speed and velocity of the project. Find the speed and velocity of the project. Take pi is equal to 22/7. So it is moving, that means it has moved in a curved path. So it is not a full path, it is being thrown from here, it is moving a curved path. So there must be a center, and the radius is said to be 7 meters. It is moving from A to B, okay, in a curved path. So it reaches A to B as shown in the figure in 10 seconds. So the from the flight to the again it is touching on the ground, time taken in 10 seconds. So find the speed and the velocity. So speed is what now is moving to the speed and velocity problem. So till now we have seen the displacement and the distance. The speed is the distance, total distance by total time. Okay, so the total distance for this movement, is 180 degree. So this is 7. So this will be pi 2 pi. R will be the total cycle, but it is half. So how much it will be? Distance. How much it will be? This is 7. 7 into theta. S is equal to R into theta. So theta is equal to pi. R you know. So T, how much? 10 seconds. So R, if I put the value of 7, so 7 pi by 10. Now the value of pi has given, so 7 into 22 upon 7 by 10. So this will be around, it is not approximately, it is a complete divisible by 22 by 10 is equal to 2.2, and the unit is given meter. So this will be in meter. So this circle is having 2.2 meter of arc. So this is doubled, the distance doubled through this path. So distance will be this, and for the velocity we have to take the least distance. The shortest distance will be this, diametrically opposite, because it is thrown from the ground and coming back from the, that means diametrically the point will be opposite. So this case your displacement will be 2r by the time 10. So 2r is 2 into 7 by 10. So that is equal to 1.4 meter. Okay. So this will be the answer. The coming next, this will be equal to 10, 11. A body travels from A to B at 40 meters per second, at 40 meter per second, and from B to A at 60 meter per second. Calculate average speed and average velocity. So till now the similar problem we have calculated the distance and displacement. This time the same problem, we started from A, gone to B, A to B, and from here the body travels from A to B at 40 meter seconds. When it is moving A to B, it is moving with the 40 meter per seconds, and from B to A, when it coming back, it has increased its velocity to 60 meter per second. Calculate the average speed. So speed average, if we take, so you know that is the total displacement, total distance by total time. So time is not given. So what we have to do? Let's say the distance on one way it is x. That means A to B is x. So B to A obviously will be a same. So the total distance is 2x. Now if it is x, so the time is x by 40 this time, and same for returning it will be x by 60 time. So total time. So obviously this will, when we calculate, we already seen what is the math behind that. 2 into this, and this is 60 plus 40. So if you calculate it, it would come 2 into 40 into 60 divided by 100. It will be 6 for the 24, 48. So 48, and what we are calculating, the average. So that means the unit will be meter per seconds. So this will be the average speed. Now if I want to calculate the average velocity, average, it will be the total distance. But total distance, you have to take displacement, not the distance. So displacement going this side is x, and the other side is x. When coming back, it will be minus x. So the time, whatever be the time, the ultimate result will be 0. So for when it is coming back to the initial point, if it is the final point matches with it, we know the displacement is 0. So it will affect the average also. So average will be 0 then. Well, for a man, who walks 720 meter at a who walks 720 meter at a uniform speed of 2 meter per second then runs at a uniform speed of and then runs at a uniform speed of 4 meter per second for 5 minutes and then again walks at a speed of walks at a speed of 1 meter per second for t minutes. His average speed, what is his average, speed average. Okay, I am writing it that person, you just read it, speed average. When I will write V average, that will put V average. For a man who walks 720 meter at a uniform speed, so initially when it is moving from some point, let's say it is a to some point B, it is distance is 720 meter and the speed is 2 meter per second. Okay, then runs at a uniform speed. So then after he started running and reaching some point C, this is 4 meter per second and time given is 5 minutes. Okay, and then after from C he started walking again and moves some distance and this time the time is 3 minutes and the speed is 1 meter per second. This is the information given. Now you have to calculate the average speed, but if you put the formula of average speed, you automatically can able to understand what you have to calculate segment, because this 3 segment is there. So every time he changes his velocity. So for first segment he has moved 2 meter per second. So on the top it is distance. So distance directly given for the first time. So 720 is given for second time. Speed and time is given. So you have to calculate the distance. So distance is nothing but what? Distance, if I say the distance is equal to speed into time. So speed is 4, time is 5. So that is 4 meter into 5 minutes is given, not in seconds. So you have to watch the time. So this is 4 into time, it is 5. 5 into 60, that means 300. So for 300 seconds is moving. So 1200 will be the distance, and the third time he has moved the distance how much? 1 meter per second for 3 minutes. So 3 minutes is nothing but 180 seconds, 180 into 1. So that means walking. So the total distance comes. So now time you have to calculate. For first case, time is not given. The time how will get? Time is nothing but the distance by the speed. Now this unit you already given meter per second. So obviously it will come in second. So how much? 360 second. So I will put 360 this time. Okay, now the second time is given directly. So 5 minutes already I have calculated. 5 into 6, that means 300 seconds. Because you have to calculate all in same unit. Otherwise it will be difficult. Or else this can be, if you want to calculate, because average speed can be calculated by, if you taken is meter per minute also you can calculate. So that case your calculation can be reduced. You can put it in minutes. So instead of seconds, if I put it 6 I put it 5, I put it 3. So that will reduce my calculation. So this is up to you how will you do it. So if you calculate, this is 1920, then 2020. This will be the on the numerator 11 plus 3 14. So with 7 it will be 300, with 7 it is 2, it will be so 150. Now you have to watch the your unit. Unit must be, this is in meter, this is have taken in minute. So if you write it correctly, the answer will be okay. If you forget the unit and put second, then your total answer will be lost, because I have taken the smallest means bigger unit to reduce the calculation. So that is my aim. But if you calculate in seconds also, it will further be multiplied to 60. That will add up the calculation, and that will be difficult for calculation. So I have reduced. So if I write it the correct unit, so the answer will be okay. If not, it is meant for calculating in second. If it is not written, so you calculate in meter per second, then you have to convert after this. So how will you convert? Because minute is nothing but 60. Now then after, finally you can change. So that will also ease your calculation. So 15 means 5 2, so 2.5 meter per second will be your answer then. Okay. So in the next video I will move on to the next problem from problem number 13. Thank you.